Assalamualaikum warahmatullahi wabarakatuh. My name is Azad Zaman from Group 10. We will present for our project group for the subject numerical method DE2402 from our lecturer Dr. Rafidah from section 5. So I'm from Group 10 with my team member, which is Amirul Adam, Amirul Adam bin Muhammad Shah and Muhammad Nazimi Afgan. For our facility provision, we use WhatsApp group and also online meeting, which is Google Meet for our task. We have been divided into three tasks, which is for the proposal simulation, which is Najmi will explain about it. Adam will explain about the manual calculation, and me, which is myself, will explain about function simulation. First of all, for the problem introduction, we will discover the numerical integration procedure for calculating a defined integral of function over a set interval, which is it cannot be direct integration. It cannot be used to fix the problem to calculate the area between the river and the beach. So we need something we need a new method to utilize the condition, which is we will use the 1 over 3 Simpson and trapezoidal method to solve the equation and the problems. For the simulation of Simpson 1 over 3 Simpson rule, I will explain about it. So first of all, with the equation, which is function for x equal to x square root 16 minus x squared power of 3, the area covered by the function between x equal to 0 and x equal to 3 over 0.5, which is we will use the same table as a trapezoidal that we have used before, and but we will solve the equation using Simpson 1 over 3 rule. Because the function so for the solution, because the function of x is integral that we need to evaluate is same as we had in the example before, so we will use the same table for the value, which is with h is equal to 0.5 for the Simpson method. And for the simulation, I will continue with explain about the simulation. So I will use the maple. This I will create a new file. So as you can see, in the table we start from 0.5 until 3.5, which is x0. We just insert x0 equal to 0.5. We need to set up a value, and x1 equal to 1.0, x2 equal to 1.5, x3 equal to 2.0, x4 equal to 2.5, x5 equal to 3.0, and lastly x6 equal to 2.5. So next we will insert the equation, which is y x is equal to x square root x square root 16 minus x square power of 3. So from the equation, we just need to change the value of x followed by the x0 until x6, which is 0.5 until 3.5. So we just need to copy the equation and just change the standard given value is x0, x is equal to 1 over 5, 1 over 5. 0.5 x0. Okay. Henceforth, we just continue with the same step until x6. 0, 0, 2, x2, 2, x2 equal to 1.5, 1.5. So you can see the value is same that you get in the table. X3 equal to 0, x4, 5, 5, 2, 3, 0, 0. And finally, for the x6, 2.5. Okay. Next, we will use the same symbol over calculation. This we need to add for the x0 and x6. So x0 plus x6, which is plus x6. You get here same. And then x2, x1, x3, and x5. x1 plus x3 plus x1 plus x3 plus x5. And we get 196 same. And finally, we need to add for x2 and x4. x2 plus x4. x2 76 plus x4 is 76 plus 1. And we get 152. The same, just like we get in table. And finally, we insert the final calculation, which is h over 3, h times 1 over 3. So h is 0.5, and is 0.5, that is 0.5 over 3. And then we need to insert the value of that we have been calculated before, which is this plus 4 times this one for the second step, and plus 2 times for the x2 and x4. This will let we click in the table for this last, the first line. This is for the first line. Second line, the sum of second line we need to add times 4, and for the third line we need to add by times 2. And finally, just insert in the calculation, we get the value which is 191.504. So to get the coverage, this is the coverage between the river and the ridge. And for the simulation, we can get the value from here. Plot tools to calculate the variable learning sums. And just change just like in the equation, which is x on square root x pound square root 16 minus x square power of 3. And for the value is 0, and for the b is 3.5. The n is 6. 1 is 6. Then we use Samson rule 1 over 3. So we display the value. X times 0.5. I'm sorry, 0.5. The n is 6. Okay, we will get the value. Approximately area 191.504. So this is our result. Yeah, right. Okay, this is so that's all for the Simpson simulation. Thank you.
Assalamualaikum. My name is Muhammad Azmi Afzan bin Jan Akmal, and my matrix number is DE 200122, and I will present for assignment for the numerical method, which is book 10. Okay. So I will present for the first method, which is trapezoid method. So as we can see at screen, this is our manual calculation by using a calculator. Okay, we solve using calculator. Then for the value of h, we got 0.5 increment. So by x at x equal to 0.5 until 3.5. Okay, so this is the limit starting point 0.5 until 3.5. So the equation is yx equal to x square root 16 minus x square power of x power of cube. Okay, so this table is the answer for fxi. So the first value is at 0.5. The answer is 31.25. Okay, until value 3.5, we got 25.42. Okay, so the total sum of xi for the 1 and 7 is 56.67. So 2 until 6 is 349.52. The answer of the sum. So we got the answer for the integration of this equation. We got 188.9275. Okay, so this answer for manual equation. So we want to prove in the mathematical software, which is I use Maple to prove. First, we need to declare the x I first. Change to 0.5. So second x2 is 1.0. Then x3 equal to 1. X4 is equal to 2.0 is 2.5. X6 is equal to 2.0. And then lastly x7 is equal to 3.5. So this is the xi. Then so we need to put the equation like x equal to x square root 16 minus x squared power of cube. Okay, so after we declare the equation, just copy. Right. So we need to prove each fxi answer. So we change first x yx equal to x1, and then change the value, substitute the value of x equal to xi. Okay, so 0.55, and the first x1 is answer for x1 also same, which is the 31.5. Then second change is equal to 0, 0, enter, and this is the answer for x2, which is at 1.0 equal to 58.05. Second is 3, 1.5. So the answer is 76.547 for x3. So same x4, which is 2.0. So just enter, for the answer is 83.313. So I must same with this answer. X5, X5, 2.5. The answer for S5 is 76.11. For X6, which is 3.0, change the value X0. The answer is 55.56. So also same with manual calculation. Okay, at 6 with 55.56, and then for at 7 is 3.5. But the answer is 25.41. Okay. So this is the each answer for the FXI. And then then we need to calculate the equal of x 0.1 x and x 3.5. Okay, it is x1, x7, and the answer is 6.6693. So and for decimal basis, okay, so after that we equal x 1.0 until 3.0. Two, two, x4, 5, x 6. Okay. Equal 349.38. So also same with the manual calculation. So for in this table, we prove the answer is proven, and then then for the value of integration, I press, and we got 188.85. So same with this integration. Okay, then manual integration. So the answer is proven. Okay, so you find the uh, graph, which is a graph set of this equation, which is the area. So we go to tutor and find the element sum. Okay, so let's put the equation which is x square root bracket 16 minus x square square bracket is cube. So and the a is 0.5, and b is 3.5, and is 7. We choose trapezoidal rule and display. So the answer for approximate area is 189.5. For actual area is 191.4, and then almost same because the is two decimal. This is the area of the hash. This in the increment. So at the x-axis, increment at 0.5, and this is the area of this function. Loss will appear at final graph. Okay, so that's all for me. Thank you.
Assalamualaikum. Assalamualaikum. My name is Amirul Adam Masha. My metric number is CE 210138. So I would like to present about manual calculation. So here we have a calculator emulator. Sorry, my bad. So I just put the equation, which is I'm using node 7 for the tables, and then put into the equations, and start with 0, and then end with by 3.5. Here we got. So and the step with the h, which is I got 0.5. So here the manual calculation. So I got this through the calculator. So 0.5, 3.1 is the same I got till the 3.5, which is the last one. So sum with the first and the last one. I'm using trapezoidal method, which is the first sum. I need to For the first sum, I need to plus the first and the last value. So the rest of them and will be the next sum. So here are the equations. So h divided by 2 n, because of uh, I'm sorry, h divided by 2. That was the equation, because a trapezoidal, by using two element, that was the two of sum. So um, in bracket sum first, and then plus by 2 multiplied by the second sum. So I got 188.85.85. So the next one will be the Simpson quarter roots. So the method I'm using for the calculation are the same. So we will focus on the papers. So for the Samsung quarter rules is quite slightly different between the trapezoidal. So for the first sums, you need to plus the first and last value. So it will be the same, but the next one sum, you need to calculate for the second box. I mean like the second one, just like in this table. If you see, if you will be see like this. So I'm choosing why I'm choosing a Samson quarter rule because of the step getting on into seven. I mean like seven step will be suitable with the quarter rules. So uh, we need to plus the sum which are um, by thirds. The first one, and then the third one, and then the first, and then the fifth one. I mean like the odd one, and this for the last sum will be the even one. So the calculation will be h mine h per with the n, which means like how many the sum will be. So this is the three. So and then the first sum, the second plus 4 multiply by the second sum, and then the plus 2 multiply for the last or the third one sum of the third last one. So I got a 1.1, I'm sorry, 191.503. So slightly different with this trapezoidal. I think but near is with uh, I mean like the value is slightly close with the most of methods. So simulation will be appear the reason why um, this become the just like that.